Hello, Jogamers. This is the second part of limits in Calc 3. So, oopsie. Okay, so I'm gonna be doing more practice problems, so let's refresh. Oh crap. And let's do a limit of x and y approaching 0, 0 of the function x, y squared cosine y over x squared plus y to the 4. Now, so yeah, check if it's a polynomial function, and it's clearly not because of this cosine y. Okay, and so, let's do our previous method. Why don't we do, alright, let's do y equals mx and see what we get. I think this, I have on my notebook two methods, and I believe this is a method that will get you nowhere. So, let's plug in y for mx. Let me see real quick. Okay. So if y equals mx, then that'll be x cubed m squared cosine mx x squared plus m to the 4 times x to the 4. Then we tried taking out x squared. We'd probably just get 1 plus m to the 4 x squared over x m squared or cosine mx. And let's see, if we did the limit of this, we'd probably get 0. Yeah, I think we get 0 because it'd be 0 over 1 plus 0 times cosine of 0 is 1, so there's no 0 over 0. So yeah, that's just equal to 0. But we need but that doesn't generalize anything. We need to prove two cases at once. So let's get y equals mx squared. Well, actually no, I did it a different way. So here's my logic behind it. You have to think before you sub in stuff. So the problem was that y to the 4th was a very annoying term for finding a general case, because most oftentimes trying to plug in y equals mx or other type of paths, you get the same limit, probably 0, y equals x squared times m to 0 or whatever. So like, you really have to think about which one will really definitely prove that there are changing values. So I was thinking, this y to the 4th and y squared is a major problem, but I don't want it to change the cosine y. I don't want to change it to some mx stuff. So instead, I thought we should sub in x for something else. I mean, yeah, we should, instead of subbing y and x, we sub in the x for an y value. Now I was thinking that I really dislike this y to the 4th, and I need to cancel it out. So the best way to do that was, well, look at these two squared terms. If they were equal, then if they were both the same variable and I managed to make them both to the 4th power, that would be really nice. And lucky me that 2 plus 2 and 2 times 2 are the same thing. So you can write y equals my squared, x equals my squared. And what that does is m times y to the 4th cosine y, we're keeping the cosine y, and we get m squared times y to the 4th plus y to the 4th. Look how simple it now is. If you can't plug out the y to the fourth, you just get m over m squared plus 1 cosine y to the limit. As y approaches 0, I'm excluding the x for I don't care about it. And this is just 1, and there you go. That's how you prove that for any m value along this path, it will change. It will change based on m on this curve of x equals x equals my squared. What was that? Alright. So let's do another problem. Let's see. Alright, oh my god. Let's do an easier one. The limit of, hold on, let me see the real question. Alright, so we got the limit of x approaching 0, y approaching 0, of x squared plus y squared over x squared plus y squared plus 1 square rooted minus 1. So, how do we solve this? Well, first of all, this is a polynomial function, but more specifically a rational polynomial function. And if you plug in 0 for x and y, you get 0 over 0. Now, just because this happens doesn't mean we can't solve the limit. Like we said, it's continuous as long as the denominator is not 0. But like I said, but it is 0 now. But it's just a matter of how you see the equation. So, notice this minus 1 here. This minus 1 can be seen as a difference in squares. So if we just multiply it by its conjugate, so we multiply this by square root, I'm not writing all that, square root this plus 1 over square root blah 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 plus 1. Now we get u squared minus 1 form of this, and the squared of the square root is just the terms inside. So you can write this as x squared plus y squared times x squared plus y squared plus 1 plus 1 times x squared plus y squared plus 1 minus 1. And then notice that these minus 1 turn into 0, and then you can cancel this, and then we get x squared plus y squared plus 1 plus 1, and the limit of whatever turn into 0, 0, 0, and this would equal 2. That's all. So all you need to do. That was easy, huh? Also for this question, the direction for it to show was to find the limit or show it does not exist. And I'm not showing that it does not exist. It's easier to show that it does exist. You know what I'm saying? So for any easier questions that does not have the denominator equals 0, just plug it in directly. Yeah, I'll show you a different problem now. Some of you guys might be wondering from the previous problem with y squared. Wait, let me see actually. Yeah. Some are asking, well, the previous question was 0 over 0. How are you supposed to know that that was actually the limit actually did exist even with the 0 out of 0? And it comes down to just looking. Typically speaking, functions with lower power, like x squared, y squared minus 1, function like this, even though it's 0 over 0, you generally just gotta think about the equation at hand. So like, what if I had y equals x, and you have 2x squared equals 2x squared plus 1 minus 1. I said we did that at L hospital. I'm just testing them. I could probably be wrong, I'm not gonna lie. And then 2x squared, so that's 4x over 2 square root 2x squared plus 1. Cancel those out. So that'd cancel, and all we're left was 2x squared plus 1. And you'd still get 2 as your answer for the limit of x approaching 0, whatever. So, I mean, you can't directly prove it, I suppose. I mean, you probably could, but, well, I know ChatGPT said this to me. So, oops. So, this is what ChatGPT had to say. If the variables depend, like x and y, if they depend, if they're singled out, like in the denominator, like x squared plus y squared, if they're dependent of this, usually the limit does not exist, because this is a directional thing, and this is like going outside the method, bro. But if it was like x squared y squared over like x squared plus y squared, like assuming you cannot simplify this, because these squares are directional, usually points to there's only one direction that limit can point to. But when, just think about how the variables interact with each other. Just think, does that one variable interact with the other ones in a way where it goes outside the direction, the intended direction? So like, if the function is not symmetric like this, where both of these are not, how should I say this? Directional? Let me think. Yeah, so like, you need to have both the denominator and numerator symmetrical. They need to have both like a power of an even number to point in a certain direction, otherwise it's most likely not exist. And here's an example of does exist pi x. Let me see it quick. So although this limit for this question does not go to 0 or whatever, it's 612 for x, y, and z. Because this has a domain where x plus z is greater than or equal to 0, and these numbers, 6 plus 2 is obviously greater than 0, that means it's continuous, and cosine pi y is just continuous in general, especially at 1, because of that pi term. I mean, cosine is just continuous either way, so since these are both continuous, they work. But I don't need you to know that, whatever. On to the next thing. Alright, let's do an easy problem about squeeze down first, and I'll do a harder problem next. Limit to x, y, 0, 0. No, I said this before that x, y, and symmetry and all that might not exist, but this definitely exists. It's probably because the square root makes these make the functions powers equal, because x squared square root is x, and whatever. Anyways, we're gonna use a squeeze then. So we're gonna look for an x squared, and we'll write that x squared plus y squared can only be greater than or equal to 0. This is a true fact, not disputed. I mean, if you graph the function, like, yeah, and then you can, and then the inequality would be inside here. There's no negatives. You can't have a negative. It can't be negative because of the two squared terms. So it's any value inside the circle, which obviously is greater or equal to 0. Now, extending that, the square root of it should also be um greater than 0, because if we just square rooted this, plus or minus, same thing. So whatever, I don't care. But this is the plus, by the way, so. Okay, so then we should know that this x squared y squared term probably shouldn't be 0, because if we plug in 0, it would be 0 over 0.
You know the type,
Or I don't know where I
before the
was at
sun,
first,
early
but
morning runs,
I think I
first
said
one to the
x
office
squared
with
plus y
donuts
squared.
and a smile. How do they
This
do
is
it?
less than or equal to
Easy. With
0.
the new Galaxy Watch 8, sleep tracking and personalized
Forgot why I
insights from
even did
Samsung
that, but
Health help you
whatever.
improve so you can
Anyway,
wake up to a
so
whole new you.
what
Your
we're really
brain,
gonna
dare I
do
say it,
is
skips the
the
snooze.
absolute value
It's
of x,
possible.
y,
Train your
square
sleep
root of
with
x
Galaxy Watch
squared
8.
plus
Learn
y
more at
squared.
Samsung.com. Requires compatible Samsung Galaxy phone
And
with
it's gonna
Samsung
be
Health app
less
and Samsung
than or
account.
equal to something, alright?
Hey Bellingham, Alan Stone is
And
coming
this
for one night only.
something,
Don't miss out on the Resilient
I'll
Project's first annual
show you
benefit
something.
show
Oh, yes,
featuring
that.
Alan Stone. Thursday,
Um,
November 13th at the Mount Baker
x
Theater.
minus
Experience an
y
unforgettable night of
squared
music and impact. 100% of
equals
proceeds directly support the youth
x
and families they
squared
serve.
minus
Tap now to get your tickets
2xy
today and be part of the impact.
plus y squared, right? And by the way, this is also less than or equal to 0. I mean, not less than, it's greater than or equal to 0.
Hey, Matthew McConaughey here with a quick
And so
reminder that, guess
therefore,
what? As you know, life
xy
is short. So what we
is
gotta do, make sure to have
greater
some
or
fun.
equal
You know what
to,
pairs well with fun?
wait, no,
I do.
less than or equal
Unalonis organic tequila. That's right. Make sure to
to
drink
x
responsibly
squared
and
plus
enjoy.
y squared over 2. That's slight. Boom, 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 boom. And if we use the absolute most greatest value of this, which is the ain't nothing but a broke boy. If xy is equal to or less than x squared plus y squared, meaning this is greater than this, if we substituted this in, we can also conclude that whatever is on this side is either equal to or greater than this. So what I mean by this is, we substitute xy with this x squared plus y squared over 2. Now, this is true because at the very least it's equal to it from here and here, but other than that, it must always be greater than this. This term must always be greater than this, because we wrote that this is greater than xy. So at the very least it's equal, but further than that, it's always going to be greater. So this is why this is true. And if we simplify it, we get 1/2 and then square root x squared plus y squared on the top instead of the bottom now. And the reason why we did the absolute value is so now we can do 1/2 root x squared plus y squared. And now we can squeeze this term. Now we can now squeeze it. So this is negative squared plus y squared. I don't know if we do the limit of either of these functions, the limit of this approaching 0 for both variables is 0, this going to 0. So when something, say f, a function f, is between two values and for this instant it's 0, and that means f is equal to 0, or at least at that point a is equal to 0. So by squeeze theorem, the limit as this approaches 0, we squeeze it and we find a limit of these that we know for sure are 0 and 0. Therefore, this is also 0 for the limit. Alright, that's all.